Section number 35 is entitled Adding and Subtracting Unlike Fractions. That means adding and subtracting fractions that have different denominators. Suppose you have 3 over x plus 4, and you're going to take away 2 over x. And think of the x plus 4 as being in brackets, 2 over x. And you need to find the LCD. The first factor is x plus 4. I did not write that down yet, so I write it down. It is not x is a factor and 4 is a factor. The whole thing, x plus 4, is a factor. So when I ask, did I write down x yet, the answer should be no. Because this is not x, it's x plus 4. Did I write down x yet? No. Generally, you would put it in front. Now, I need to rewrite these two fractions with the same denominator. 3 over x plus 4 minus 2 over x. Now, I want to change the way they look. That is, I want each of these fractions to have this denominator. If you want to change the way something looks, that's code for you want to multiply by 1. I cannot stress this enough. If you want to change the way something looks, that means you want to multiply by 1. You want to get stuck, don't know the right way to write 1 down. But know you want to write down 1. You want to take 3 over x plus 4 and multiply it by 1. And when you multiply it by 1, you want to get this denominator. Well, I already have x plus 4. If I multiply it by x, I'll have my denominator. Multiply by x. X plus 4 times x is the same as x times x plus 4. Now, if this fraction has any pair on equaling 1, whatever in the bottom in here must be on the top. X over x is 1. Okay, we're assuming x is not 0. After all, if x were 0, then the beginning problem makes no sense anyways. Now, the second fraction has x on the bottom. It has the x factor. It does not have the other factor, x plus 4. So I want to change the way it looks. That means I want to multiply by 1. Well, if I put x plus 4 in the bottom, then my denominator will be x times x plus 4. Just what I want. Well, I better do the same to the top. Okay, so in subtraction, if the bottoms are the same, keep them. This bottom is x plus 4 times x, and this one is x times x plus 4. It's the same. X times x plus 4. The numerator is 3x. Take away. So you really need to put brackets. 2 times x plus 4. That is 2x plus 8. And now I'm almost done. I need to do this subtraction. 3x take away 2x is 1x, or x. And I have to also take away positive 8. Positive 8 is just 8. I have to take away 8 as well. And there's the answer. There is your answer. That's what you get when you subtract these two fractions. And still, if you plug in 0 for x, it's nonsense because you'll be dividing by 0. If you plug in negative 4, it's still undefined. It's when you cancel out is where you're going to have trouble. Okay, let's try another one. Okay, suppose you have 3y, and you want to take away 1 over 3. denominator. So that's the only thing I write down. That is the LCD. So I want to take the first fraction and get it to have a 3y in the bottom. Since it does not, I need to multiply by 1 minus, I want that second fraction to have a 3y in the bottom. But it does. You don't have to do anything to the second fraction. But the first fraction, remember, there's an understood 1 down here. 1 times 3y is 3y. Now, this product will have 3y in the bottom. And since this fraction must be 1, I have to put 3y in the top. And 3y times 3y. Well, there's 3 times 3, and there's y times y over 1 times 3y, which is 3y, minus 1 over 3y. Now, it looks like I'm doing this correctly. My denominators are the same. Subtract the numerators. 9y squared minus 1. Now we can factor this. The difference is squared. 3 squared is 9, and y squared is y squared. So this is 3y squared minus, and 1 is 1 squared. So I'm squaring 3y and 1. Write it down 2 times. 1 gets the minus, 1 gets the plus. The bottom is, I meant to write down 3y. The bottom is 3y. And here is your final answer. Let's try another one. These similar ones in your book. Now, I'll show you a nice way where you can get at least a partial check. You have 5 over a over 3 over a plus c. First, let's get the answer, then we'll look for a partial check. A I didn't write down yet, write it down. A plus 3 I didn't write down, write it down. That's your LCD. You want to take 5 over a and multiply it by 1 such that the denominator will become this. Well, I already have the a. I need to multiply by a plus 3. Top and bottom. That guarantees me that this fraction is 1 minus the other fraction, 3 over a plus 3. It has the a plus 3. It has this. It's missing the a. So when I multiply by 1, it's going to be a over a. Because a plus 3 times a is the same as a times a plus 3. My denominators are the same. A times a plus 3. The numerators. You have 5a plus 15. 5a plus 15. And you have to take away 3. Well, 15 take away 3 happens to be 12. So here is your answer. Or here is what you claim your answer is. Now remember, the top left and the bottom right, they're equal. Unless we made a mistake. That is, we're claiming that 5 over a minus 3 over a plus 3, they're equal. For any value of a except values that make it undefined. For example, I can let a be 1. I can let a equal 1. Well, 5 over 1 is 5 minus, if a is 1, 1 plus 3 is 4. 5 minus 3/4, so we're testing a equals 1. We're testing a equals 1. 5 minus 3/4 is 4 1/4. Okay, that's what the left side equals. That's what this equals when a is 1. When a is 1, This will be 5 plus 12. 5 plus 12 is 17 over, if a is 1, 1 plus 3 is 4, and that'll be 1. 1 times 4 is 4. But that is 4 1/4. 4 times 4 is 16, plus 1 is 17. 17 over 4. Okay, does this guarantee us it's right? No. Possibly we made a mistake and they actually work out when a is 1. But trust me, they won't work out when a is 2. The nice thing is, if it does check, you're probably right. But if it didn't check, and you didn't make an error in your check, if it wasn't equal, and you didn't make an error in your check, then go back and find out where you went wrong. Because you definitely made a mistake. There's no way around it. You made a mistake. So it's a nice check. And generally, I would plug 0 in for a, or the variable, except the denominator was a times a plus 3. If a is 0, then you would have 0 times 3, or 0. And you can't have 0 in the bottom. Okay, let's continue with one more problem. Suppose you have 4 over x minus 5, and you would like to add 6 over x plus 5, and you want to take away 13 over x squared minus 25. That means, so the first thing is, you want to find the LCD of these 3 fractions. The first of these 3 denominators. The first 2, x minus 5, x plus 5, they're factored. Can't factor it anymore. But the last one is x squared minus, it can be thought of as x squared minus 5 squared. That is, x and 5 are being squared, and you have a minus in between. So that's easy to factor. X minus 5, x plus 5. Let's find the LCD. I didn't write down x minus 5 yet. I write it down. I didn't write down x plus 5 yet. I write it down. I did write down x minus 5. There it is. And I did write down x plus 5. There it is. So that's the LCD. Sometimes we'll like to see it as x squared minus 25. Other times as x minus 5, x plus 5. But nonetheless, that's the LCD. So now, I have 4 over x minus 5. So I want the denominator to be x plus 5 times x minus 5. I already have the x minus 5 right there. So I need the x plus 5. So I multiply top and bottom by x plus 5. And that's it for now. Now I add on the next fraction. 6 over x plus 5. But I want the denominator to be this. Well, I already have the x plus 5. I need the x minus 5. So I multiply top and bottom by x minus 5. Minus the next fraction, which is 13 over x squared minus 25. But that is my LCD. I don't have to modify it at all. If you insist on modifying it, that is multiplying by 1, multiply by 1 over 1. And now we have each fraction, each term has the same denominator. Is exactly what we wanted. This term, and this term, and this term, the 1 over 1 is silly. They all have the same denominator. X minus 5 times x plus 5 is the same as x plus 5 times x minus 5, which is the same as x squared minus 25. So the denominator is the same. You should really leave it in factored form. The reason you should leave it in factored form is, let's suppose, well, there's two cases. You did leave it in factored form and you did not. Let's suppose the numerator was, after factoring, 3 times x minus 5. 3 times x minus 5. That's not the right numerator, but let's suppose it was. In the first case, I think it's very clear that you see that canceling out. It's not as clear over here that x minus 5 is in the top and in the bottom, and you can cancel it out. So, you really should write the denominator in factored form. Do you have to? No, but might you not? Is it possible that you won't see obvious canceling out if it were in factored form? Yeah. In a factored form, it would be obvious, and in non-factored form, less obvious. Okay, what are the numerators? You have 4x plus 20. 4x plus 20 plus 6x minus 30. 6x minus 30 minus just 13. Okay, so we have numbers and we have x's. X minus 5, x plus 5. Let's do the x's first. You have 6 x's, and you're adding, I may have said 6 x's. You have 4 x's, and you are adding 6 x's, and that's it. That's 13 x's. You have positive 20, which is 20. You have 20, and you're adding a negative 30. That's negative 10. And you are taking away 13, which means you're taking away 23 in total. And you cannot factor the numerator, so there is your final answer. Get the denominators to be the same by multiplying by 1. And that finishes the section on adding and subtracting unlike fractions. Good luck with them.